Cool, we're good? All right, okay, I think we're gonna get started. Before we start, I wanna do a quick query. How many people here have already deployed some sort of streaming app solution on their cluster or environment? Okay, and how many people here are thinking about deploying some sort of modern application? Okay, neat, awesome, excellent. Well, my name is Edgar. I study computer science at UC Berkeley, and I've been with Hortonworks since last year. I work on Scala and Java applications using Apache NiFi, Storm, Spark, Kafka. I work with the Sandbox team to develop an environment for deploying data applications, and with the marketing team to write documentation and tutorials around tools to help developers get started. So, historically, most data processed by systems were sourced internally, right? Think data from data lakes, cold storage, data that's been sitting around for a few days. But with the emergence of the Internet of Things and really the Internet of everything and anything, this trend has shifted. Now everything has the ability to sense, to communicate, and to compute, and quite efficiently. And so the convergence of these has created an enormous opportunity for large-scale and distributed data computing. This isn't just a fad. This is growing at a furious rate. If we're talking about 4 zettabytes today, then we're talking about 44 zettabytes by the year 2020. So at the keynote this morning, you heard George Vedekinen talk about this use case of a trucking company, and it's a very powerful use case. It covers a big part of the real-time streaming applications spectrum, and so that's what we're gonna. So I'm using that use case. So the problem here is that there's a company, they're a vehicle dispatch company. They deliver cargo across the country, and they dispatch drivers. But recent string of accidents have meant increased insurance premiums, more collisions, and sort of just a overall lower quality of service. And so they want to decrease their insurance premiums, bring up their service, all while their competition is getting a leg up. So they have a hunch as to what they want to do, but as you all know, company changes shouldn't be driven by hunches. They should be driven by real data, actionable insights. So the solution: leverage real-time data, install sensors on the trucks. Bring that data into whatever system or environment they're using. They'll want to do some sort of analytical processing and visualization, so they have actionable insights, something to actually show the suits, and make some company-wide changes. So that's prescriptive analytics. But what about some predictive analytics? What about making changes before bad things happen? And so they'll also want to do some machine learning using real-time and historical data for more accurate, precise insights. So this is a big undertaking. It's not very easy. You have this is a big old this is entire end-to-end pipeline. This isn't one of those cases. This is probably the only case where you can't copy and paste code straight out of Stack Overflow. If you were to look up samples for building components that belong in a real-time streaming application, then you may find some. But you'll find that a lot of the code samples are isolated to one component. They don't necessarily consider the up or downstream components that come in with them. They're not necessarily swappable. So when your requirements change and your data evolves, then you're kind of stuck having to re-architect your solution. And maybe not re-architect your solution, but definitely more work. A lot of the stuff out there isn't documented, and if it is, a lot of times it's outdated. We can't use antiquated tech, especially now with the emergence of all these amazing services, and we have to keep up to date. So it doesn't matter if it's like a very simple sample, something like tracking livestock, or if it's a sophisticated point of sale system for a fast food company. You're going to be looking at lacking documentation, and you're going to think, where's the beef? So wouldn't it be awesome if there was a reference application built on top of true open source software? It was fully sourced, fully supported, followed a single use case, and had code samples for every stage, for every service of every stage in the pipeline, and on top of that, it was supported. So as tech evolved, as requirements changed, this reference application would have you covered. Right? Well, I think that'd be pretty neat, and that is exactly what we have for you guys today. So let's take it out. Let's take it off for some sweet jumps. Let me not forget to share my screen here. So this is going to be a very quick demo. We're going to get into it a bit more, but I just want to point out two things, and then we'll get into it a bit more in a minute. So for those of you who aren't familiar, this is Apache NiFi. And we're going to get into this in a second, but I want to point out two things. One is that this little box here, a processor, as NiFi calls it, is where all the data is being generated. This is our edge, right? This is where all the sensor data from the truck is being originated from. In addition to sensor truck data, it's also streaming traffic congestion information from some online service. So wanted to point that out. And what we're going to end up with, as you saw George outline this morning, is something like this. So this is a visualization dashboard, and we've got analytics happening in real time as data is being streamed in from the edge. So we're going to get back to this, but I just wanted to give you guys a taste of what we see. So I think that was pretty flippin' sweet. So just a very quick overview. What we're looking at here is we have the Internet of Anything, so our truck, this data from our truck, it's going to be ingested by NiFi. It's going to be routed to a Kafka topic, and then we're going to ingest that using SAM, Streaming Analytics Manager. We're going to dump it into a Druid data store, and then we're going to ingest using Superset, which is our visualization dashboard for OLAP and analytics. We're also going to have a sneak peek of some really cool things that Hadoop 3 does. So Apache NiFi. So one of the things that I sort of dislike when I look for sample applications online is that everybody seems to be doing the same thing. It's sentiment analysis on Facebook feeds or word count on Twitter feeds. And this is great, but what about the stuff that actually matters? What about like the things that our companies are tackling, right? Our day-to-day jobs. You have genomics researchers ingesting from arrays of data sources, and they're doing more than just like reading data from one source, routing the data through some processing engine, and then saving it to like our local file system. It's much more complex than that. And it's that reason that we're going to use Apache NiFi. Data nowadays is very incomplete. There's a lot of heterogeneity, and it's becoming the norm, not the exception. So we need to have intelligent routing. So going back to our demo, let me share the screen here. But going back to the demo, what NiFi allows us to do is allows us to intelligently route and filter data. So here we have truck data coming in. We're going to split the data into two streams: truck data from the truck from sensors, and traffic congestion information. We are going to enrich the data, and we'll talk about this a bit towards the end if we have time. We're going to enrich the truck data with weather data from a real-time weather data service. We're going to tag it with the name of the Kafka topic that we want to store it in. So effectively, where do we want to store it? And then we are going to publish it to Kafka. And we'll skip this part here, but it'll make sense in a minute. And so that's just about it. That handles our flow. That is our flow management solution. So the next step is Schema Registry. So in a data application, each one of your services needs to know the data that's coming in and where that output is going. You have to do this in each service and in each stage of the pipeline. It's for that reason that most of us serialize our data packets, and we make sure that it adheres to a scheme. Any engineer here knows that scope creeps. Data changes as your services evolve. If your scheme is brittle, your application is brittle. And if your application is brittle, then things start to fail, and you can't have that. So we use Schema Registry. In a nutshell, it's a centralized repository for storing evolving schemas and its serializers and deserializers. So that's when reshare the screen. That's what this processor that we went over, that we skipped rather, is doing. So all this is doing is it's data agnostic. What it's doing is it's taking data in, and it's putting in a format that any other component that integrates with this registry is going to be able to read. And just a very quick look at what the interface looks like. Although, pretty straightforward. But really, it's just we're just registering our schema. So one of the really neat things that Schema Registry does is you don't have to worry about about writing or defining your schema in each one of your services. You integrate it with the Schema Registry, and the service communicates with the Schema Registry, and then it handles matching the impedances of the format and the scheme from point A to point B. So you're totally hands-off, even when your schema evolves, which is great. So real quick, a quick checkpoint. We've got NiFi intelligently handling the routing and filtering of our data from any number of data sources to any number of endpoints. We've got Kafka as our message broker, streaming the data between services and applications that we may have connected. And so now we have to choose our distributed computing system. So there's a lot of options: Apache Storm, Spark. You can use more Kafka, Akka Streams, Flink. And they're all great, but they definitely all have their flaws. There are some serious challenges with the tools that we've engineered this far. One is there's typically a lot of low-level coding, and if you can't, if the documentation fails you, you better know how to dig into the internals and figure things out using the source code. Depending on the framework, there's a lot of boilerplate and a lot of dependency issues. I don't know how many of you that have worked with. In fact, hands up if you just real quick. Hands up if you've actually written code for like Storm or Spark or any sort of processing engine. If you can keep your hands up for just a second, okay. And and you can put your hands down if you have not run into any sort of dependency issues or boilerplate issues. So a couple of you have actually put your hands down. Most of you know my pain. And so development cycle is not always fun. So, I love my Scala, my code editor, and my energy drinks as much as the next engineer, but sometimes you just want to get your flow down. And that is why, for this example, we're going with Streaming Analytics Manager, SAM. It's a visual stream builder, so it uses a drag and drop paradigm. And one thing that actually surprised me when I started working with it is that it's the only open source visual stream map builder on the market. So let's check out a quick demo here. All right, so this is an app we've got pre-built, and it's going to be a simplified. It's going to be a simpler version of what you saw this morning, just to sort of demo some neat things here. So here we're ingesting data from 2 Kafka topics. We're joining those streams. We're going to filter on two different rules. One is safe driving events, and we're going to dump that into a Druid data source, which we'll get into in a second. The second is we're going to filter the violations, and we're going to send that to another Kafka topic and also to a Druid sync. We're going to calculate the average speed of the drivers and also send that to Druid. So just to show you how easy it is to build something like this, let me show you legit what I actually had to do. So I bring in 2 Kafka sources. The first one, we're going to select security protocol. Our servers are automatically filled out for you. This one we're gonna ingest from our traffic topic. This one we're going to ingest from our truck topic, and we hit OK, and we want to join those 2. We want to join those 2 streams on route ID and inner join, let's say every 20 seconds, and we want to select all of the output fields, and it integrates with Schema Registry, so it knows exactly how to read everything and what format to output it. And that's like legit it. That is what I did to get a 3-node, 3-processor app going. So we could deploy that, and that would work. Like that is like legit all I had to do, which I think is pretty amazing, because it would take me like 2 years to write this in like Flink, right? I'm kidding, of course, but still, right? Yeah. So let's get back to this. We're going to skip the web app, but there is sample code for everything you see here. There's going to be sample code. You follow the link on the bottom. There's sample code for getting a Play Framework app up. But yeah, let's skip that part. So yeah, that's neat. So Apache Superset, at its core, is just a data exploration platform, but you're able to perform analytics and create visualizations. And it's meant to be visual, intuitive, and very interactive. Let's bring this up. Okay, so this is really neat. Excuse the loading time because I know we have some network issues. Yes, so each one of these dashboards are being populated with real-time data. So we can go into any one of these dashboards. So let's see what we have here. We have 10.4% of all violations were done by Oksana, and of those violations, 20% were speeding violations. So that's very naughty. George really likes the sunburst one, and so do I. It's really neat, and I kind of want to build this on the spot just to show how easy it is. So let's create a new slice, which is just like a new little dashboard slice. Let's perform this on the violations events, and again, there's documentation and walkthroughs on everything you see here in the GitHub repo. So let's check out. Let's get a sunburst visualization. Let's have our hierarchy be driver name, a type of violation, and then the route that the violation happened on. Whoops. And let's query. And holy moly, that actually works. And this is working on real-time data, which I think is pretty sweet. And it really is that easy. And again, there's demos and documentation and code and everything in the repository. If it's not, then maybe I just forgot to get push. But there will be, or there is already like 95% there. So and the link is on the bottom, and we can go over that in the end there. So just to recap real quick before we get into something else, again, we're ingesting data from the edge, filtering it through NiFi, using Kafka as our message broker, then ingesting that with Streaming Analytics Manager to actually build the streaming application. So that streaming app is built by Sam. From there, we dump data into a Druid data store. So Druid is a high-performance data store, and we're ingesting that data into Superset to actually perform these analytics and visualizations, or visualizations of the analytics. And again, so you have NiFi, Kafka, and Streaming and SAM all integrated with Schema Registry to handle sort of those evolving schemes and formats for you. So sneak peek of Docker on Yarn. This is something I'm actually I forgot about this slide. Okay, so real quick, some typical challenges, some things that I ran into is, especially when you're working with different applications, multiple applications on the same cluster, because most of us aren't going to, spin up entirely new clusters for our applications. A lot of applications and services have conflicting requirements, maybe right, like maybe different versions of like Kafka, or even like CentOS S, right, CentOS S or whatnot. Sometimes there are a lot of environment changes. Like typically, if you're working on a Python app, there's a ton of things you have to install on your OS layer. And those two make continuous integration not trivial. You can improve that by using an automation server or an automation script, but even then it's not necessarily super easy. Or if you just want to be agile and like move, then there's, that you have to amortize, and it's like sometimes you don't want to put in that time to begin with. So one of the approaches that I found super useful was actually spinning up a new cluster. And what I do is use the containerized environment. The one from Hortonworks is awesome. It's free, you can check it out. What do we got? So that's one of those challenges, but with the new version of Hadoop, there is a new challenger on the block. So Docker on Yarn is something I think I'm really excited about. So in a nutshell, your Docker on Yarn, you're able to bundle your applications, including all services and requirements, down to like the version of the OS that you want to use, bundle that up into a Docker image. So you get this Docker image, and then you tell Yarn how you want to instantiate this Docker image. Like you can pass in configurations, and you define this JSON, you pass it in, and it wires the different images together. We'll see sort of a demo of this in a second, but you can define a bunch of different Docker images, you can wire them together, and then Yarn runs it on your cluster as it does any other Hadoop job. And so from like a continuous integration standpoint, it gives like much better development cycles, and you're no longer worrying about like conflicting requirements and like, is it even possible to have like 10 different Kafka versions on your cluster? With Docker on Yarn, you don't have to worry about that. So all right, so let's see if we can get into this demo, because this is something really neat. So the first thing we do is we create a Docker file. Oh, there we go. Let's share that screen here. So the first thing we do is create a Docker file. So here we are we're going to base our Docker file on just some base image, and this is just like a really thin Linux layer with like Java 8. That's all it is. We install Kafka as part of the container. We expose the port. It's not necessary. It's just there for more documentation purposes. And then when the container is instantiated, we run this command. And so that's it. So this creates a Docker image just like any other Docker image is created, right? If you're familiar with Docker, then this is nothing to you. So the next step is you have this Docker file, or rather this Docker image created, and then now you define a JSON that you pass into Yarn. And so we won't go over this thing in detail, although of course you can if you go to the repo. We give the service a name, and then we start to define all the different components in this assembly, as we call it. So this is, and we call this whole thing a YAR file. So we want a Kafka broker, and we want 3 of them. So we want 3 Kafka instances. And here is the Docker image that we just created. So we just tell it where the Docker image exists. We can allocate as many resources as we need for each one of these. And then we pass in how we want this node to be deployed, with what properties. We do the same thing with every other component. So we also want Storm Nimbus in there, right, as our streaming engine. Here is the Docker file, or Docker image that we built, resources, and how we want, the configs that we want the image deployed with. So we'll just skip all the way to the bottom, and we'll notice that we also have a trucking web application. And so we have, where'd it go? We define the Docker image. We point to the Docker image that we create, and so this one I've already pre-created. And what command we want to launch or to be executed when the container is up. And again, the properties that we want to launch the container with. So I don't know if you see a pattern, but as you saw, the Kafka Docker image was built very generically. There was like no special configuration. There was really nothing special being done. It was a very blank, plain Docker image with Kafka installed. And so if you're tracking the pattern, you have a bunch of these super generic Docker images, and you tell Yarn, right? You tell your cluster exactly how to wire these together. So you say, I want this like Kafka container. I want the Storm container. In fact, I want like 3 Storm, 3 deployments of Storm. I want my trucking app. I want this and I want that. And then all of the configuration, all of that special non-generic stuff, you just throw into your JSON definition. And then you get that JSON definition. You post, and here, let's actually send. Right, okay, sweet. Network isn't letting us down. And then with the really sweet new UI that's part of Hadoop 3, and I should mention that this is still a work in progress. This code is a branch in the Hadoop 3 trunk, so it's not necessarily yet part of Hadoop 3. But let's refresh this page. Sweet, and then we see our new service there. It is now running. And so in case the network went down, I also had these pages pre-opened. So here's some information on the service that we just deployed, this assembly. We can go down to components, and while that loads, I'll just bring up the actual page. And then this gives us information into all the different components that we deployed. So you see that we have 3 Kafka brokers. We have 3 Kafka brokers, right? We also have Nimbus, Storm Nimbus, Supervisor, 3 components that deal with the trucking application that we just went over, the Storm UI, how much memory they're taking up. And so the demo that we just went over, that is deployed for you. It's being run just as any other Hadoop job would be, and it'll be long lasting. So if for some reason it comes down, then then Hadoop will bring it up for you. We'll try to bring it up for you automatically. So that was I'm really excited about that, and for that reason, I think Hadoop Yarn is pretty off the hook. So what's left as part of this project? So I'm glad we have a little bit of time left because I do want to mention that everything you saw here, again, is part of the repo. It's as documented as I could make it, but feel free to, to look at it and say, like, Edgar, your code sucks. Like, here's a pull request, make it better. Like, please, like, I'd be happy if you did that. So what's left and what's actually in the repo that we haven't demoed today? So we have plug and play examples of using different streaming engines. So we use SAM, but we also have examples of using Storm if for whatever reason you don't want to use SAM. We have examples of using Storm, of writing a Storm topology in Scala and in Java. We have examples of using Spark streaming. We have examples of predictive analysis. So we actually have this, although I haven't implemented it as part of the demo. So it's there, but you just might have to like look around for it, but it's actually there. But it is there, and I'll get it part of like the demo with have it documented and everything. Predictive analysis using Spark. One of the things that's in the work is securing an application from end to end. Using Kerberos on your environment. And again, tons of code and documentation to check out in case something is maybe like not necessarily hacky, but like if the documentation looks weird, I'm probably in the process of cleaning it up. But otherwise, we try to leverage as many best practices as possible. In fact, at Hortonworks, one of the really cool things is you have access to like Apache committers. So I bug them as much as I can without getting on their nerves to make sure that we're approaching this problem correctly and we're architecting this the best way possible. I do want to mention that there are other talks. So there's a crash course tomorrow morning on streaming analytics, and so they go over this, the same use case or similar use case. There's also 2 more talks tomorrow. Again, link to the code and the repo. And one of the really cool things that Hortonworks does is there are tutorials around different tools. Like if you want to learn more about Ranger or Kafka or Storm or a NiFi, what have you, there are tutorials for beginners, novices, and and if you're like a hardcore developer and you just want like to get straight into like Scala code, then we have those too. And also sandboxes, because in my case, I'm not gonna spin up an entirely new cluster to run like dev code, so I just I download something on my machine and I get it working that way. Please do check this out. If you have any ideas for things you want to see as part of a modern data application, or if you have more questions about like a reference architecture or whatnot, definitely ping me, email me, get me on, or just like yell at me from across the room. But let me know what ideas you have, and we will implement them. Really, what I want you guys to get out of this is building a data pipeline, right? A modern data application. It can seem tough, but it doesn't have to be. There should be a way for developers and especially like early developers to seed their own solutions. The industry should not make it difficult for people to get started, especially when we have all this data that's ready to be acted on and ready to do some amazing good things in the world. And so with that, I can field any questions, and otherwise, thank you guys very much. Oh, yes, sir.
How often we need to write a custom components in the SAM?
So the question was, how often do we have to write custom components using SAM? So that's a good question. So SAM comes with where do I have it open? SAM comes with a bunch of processors. And so I guess the answer to your question would be as often as it is that what you need isn't necessarily part of what's built in. A lot of things you can build using sort of these native components, but if there's something super specific that you really can't, I'm sorry, I didn't even share my screen. So these built-in components here. I guess the question would be, as often as you can't use one of these built-in ones, but there's APIs like SDKs for actually building one of these out super easily. I don't mean to put him on the spot, but if you have any questions, we've got Harsha there that can actually answer them. He's like, and then we also have the SAM team actually right down here. So you can definitely bug them. You go straight to the source. Yes, sir. So the question was with regard to NiFi integration with SAM. Is there,
On FI, you can see the data provenance of data lineage between the components, between the processors. So is there a way to do the same on SAM to see how the data has been modified?
So the question was with NiFi, you can see lineage. So NiFi, helps with like lineage and governance and whatnot. And so the question was, do you have some sort of similar interface and insight using SAM?
So SAM actually deploys the topology on Storm as application to Atlas. So whenever you deploy the topology, you have Atlas installed, it will actually publish that.
And the other thing you might want to show is in the view mode, we have that schema changing and displayed every point, right? So
Do you want to check it?
Second one question is, so what is exactly the difference between Superset and Banana?
So just so the question, right? So I repeated the question, but the response was so SAM helps you build the application, but the streaming engine, it's not necessarily a streaming engine. So it's got this unifying sort of abstraction, and you're able to build the streaming application using a number of different underlying streaming engines. And so in this example, we're using Storm. And so as far as like lineage and provenance is concerned, you can actually check out that information in the Storm UI. So because it's using Storm as the underlying engine, you have all the information as part of that Storm UI. And so you had a
if you can go to the view mode of the SAM app.
yeah. Go for it. Definitely. Community-driven development was what was said. Yes, ma'am. Question? So the question was, in this case, because we're using Storm under the hood, is there a way to integrate existing Storm topologies into SAM? And so was the question, to clarify, was the question how to rebuild the topology using SAM, or just integrate existing topologies into like a new SAM application? So as far as like migration is concerned? So I imagine that the answer is, I guess it sort of depends on what the rest of your pipeline looks like. And what if you want to keep your existing Storm topology and then you want to use SAM for the rest of your flow, but
I can take the answer. So
yeah.
it should be very easier to transfer, but you have to rebuild it. Like we can't just take the existing topology jar and put that into a SAM application. But what you have to do is kind of take that and build again from that and use the SAM to kind of move forward on. Yeah, I mean if you have your custom business logic, you probably have to build a custom process there. But most of the like join or anything that you might have to do right now can be expressed by a SAM existing process.
Oh, yes, sir.
What are some of the integration issues that you're having with Kerberos authentication?
With Kerberos?
Yeah.
So so Kerberos is fantastic, right? The thing is, so personally, Kerberos is this beast that provides this awesome, has an awesome set of like functionality. But personally, I don't do much work with Kerberized clusters, and so the bit that I've tried, I have when I'm met with resistance with Kerberos, I tend to like, it's okay, I'll work on another part of the application. Like I've got other stuff to do. Let me come back to this in like a couple weeks. So unfortunately, I don't have much insight into the challenges integrating this with trying to Kerberize this. Right, for sure. Yeah. As far as like the environment goes, like the reference application, right? But of course, each different component, right, of course, is you can integrate into Kerberos. Yeah. Yes, sir. Oh.
He's trying to wrap up.
Oh.
So let's wrap up.
Yeah.
I mean, like, you have questions, have them come
Yeah, definitely. Sorry, we can take these offline, or you could just bug me. Yeah, sorry, I didn't see the hand wave. All right. Yeah, perfect. Thank you guys very much.